Hello, thank you for the invitation to address this conference. My name is Vivi Kunduri. I'm the Scientific Director of iCreate. It's the International Center for Research on the Environment and the Economy. I'm also a professor in economics at the Athens University of Economics and Business and at the London School of Economics. My work focuses on managing natural resources and the environment, and today I'm going to be speaking about integrated sustainable management of water resources, and I'm going to be focusing, of course, on the socioeconomic considerations, which is my work as an economist. In this slide, I briefly mentioned the work that iCreate does. iCreate is a non-for-profit research institution that focuses on interdisciplinary work in managing natural resources. Our goal is to contribute to the scientific understanding but also implementation of sustainable development as the only non-self-destructive path of socioeconomic development. We have an extensive network of very important researchers in the field, and we hope to influence not only science but policy making and management in the field. We have done many projects on water resources the last 20 years with the European Commission, and we focused on inland water management, coastal water management, marine offshore water management. We have done projects all over the world, as you can see in this next slide, in Asia, in Africa, in the US, in Latin America, and we work we work with many international organizations as well with national governments. Let me just remind you that our aim in managing water resources is to achieve sustainable management and contribute to sustainable development. And let me just very briefly suggest that sustainable development is a pattern of resources use that aims to meet human needs while preserving the environment, so that these needs can be met not only today but also in the future for future generations. And this is the only path that puts society, consumers, producers, businesses, and financial institutions on a non-self-destructive rotation. So let's try to see how we can bring this into water resources management. The main thrust of what I'm going to be saying today is how we are going to implement sustainable water management in order to support sustainable development. And I'm going to suggest that in order to achieve that, we have to achieve simultaneously environmental ecological sustainability, that is ecosystem resilience, the ability of the ecosystem to retain its organizational structure and function after a source. Then we have to achieve economic sustainability, that is economic efficiency by every economic sector over time and over space, an allocation of resources in a way that accelerates growth and maximizes economic value. And third, social sustainability, that is cross-sectional by income and dynamic intergenerational affordability and equity. So we are looking for environmental ecological sustainability, economic sustainability, social sustainability, and these three things happening simultaneously. We're going to introduce a manual, a very easy to follow manual of 3 steps that provides a common integrated framework for all relevant spatial scales and even time scales. Three steps. First, we have to characterize our river basin, which is usually the unit of analysis when you are doing water resources management, but you can also implement this manual at different spatial scales. Second, we're going to assess the current cost recovery level of water resources services. And third, we're going to identify the measures and investments and their economic impact that will allow us full cost recovery of water services. Now, if you look at my slide, the characterization step includes the identification of the economic significance of each of the water resources, which means that for each economic sector, you are going to identify its use of water resources and you are going to calculate the importance of this use in the output of this sector and then the importance of the output of this sector in the economy of a region, of a country, of a continent. Then you need to identify the trends in key indicators and drivers, then have some sort of prediction for the dynamic path of demand and supply of water resources, and then identify the gaps between where you want to be and where your current management will get you to. On the second step, the assessment of current cost recovery, you need to identify how much the different economic sectors, the different stakeholders pay for the services of water resources. So you need to know who pays and how much. And you need to compare what is paid with the full cost of these resources. So you need to identify the level of cost recovery of using water resources. And at the final step, you need to start thinking about cost recovery mechanisms that will allow you to retrieve all the cost of water, to retrieve the full value of water. Whoever uses water should pay its full value. The third step is the explicit identification of measures and investments and the assessment of their cost effectiveness and their assessment of their economic impact. This means a cost benefit analysis of the suggested measures that you're going to use, economic tools, awareness tools, investments, and so on, in order to manage your resources. In the next slide, I have the first step with a bit more detail. The first step will give us one important item in our analysis, which is the construction of the baseline scenario. In order to complete this step, you have to evaluate the socioeconomic significance of water resources by river basin, by economic sector, residential sector, industrial sector, agricultural, tourist, services, ecosystem. Then you're going to identify the key drivers, environmental, economic, social, and how these influence pressures and uses. And then how will these drivers evolve over time and how will they influence pressures? And then you need to predict demand and supply and how they will evolve over time and which problems you're likely to face. This analysis will allow you to construct the baseline scenario, and of course the detail and the time you're going to spend on constructing this scenario will be a function of the money you have. Looking at this slide, which is called the evolution of supply and demand over time and over space, we with this slide, I want to bring in the concept of value, which is the last bit of the first step of our manual. This is a very important step. Why? Because it introduces and tries to calculate the value of water resources. And the approach we take to the value of water resources is that the environment has structure and processes, and these give environmental functions, and these functions give ecosystem services, and uh, these ecosystem services give human benefits. And because the total economic value is an anthropocentric value, we try to translate these human benefits into monetary value. And it is worth highlighting here that values are the economic value is the summation of use values and non-use values. Actual values, direct and indirect, option values, but also non-use values. The value I give to the continuation of the existence of something, or the value I'm willing to pay in order to sustain something for my children, for others as a bequest value, or for the rest of the society as an altruistic value. So, what is important here to remember is that the total economic value that will give us the demand of water for each sector in our river basin, which will allow us to have a complete characterization of water resources demand in the river basin. It's a value that is not readily available in markets. Water resources are public goods. There are no explicit property rights. They are not explicitly, because of that, they are not explicitly traded in markets. And with no markets, you have no prices. And in order to retrieve the value of water, you need to use other methods that will allow you to do so. So prices are not there. If we had prices, we would have the marginal value of water resources. Now we don't have that. So in order to retrieve the demand for water resources, we have to use non-market valuation methods. And unless we have the demand and supply of water resources, we will never be able to manage the resources sustainably and efficiently and equitably over space and time. We economists and my group for the last 20 years have been developing ways to retrieve these values, both use and non-use values. And there are two basic broad categories of values, and in this slide you can see the reveal preferences method and the stated preferences method. Use values can be retrieved by using reveal preferences methods, especially if you have a market working. For example, agricultural products are sold in a market. So the production of agricultural products that uses water as an input can be used in order to retrieve the value of water. There are many techniques that are basically econometric techniques with clever ways of retrieving the data that you need in order to econometrically estimating the demand. And for the reveal preferences method, we have hedonic pricing method, which basically identifies a market which works closely to the water values that we are interested in. For example, the market for agricultural land. If this market for agricultural land is closely connected to the existence of, let's say, groundwater in this land, on this land, under this land, or the agricultural land is connected with a property rights on the water, then it is doable to use the information from this land, from the value of land, in order to retrieve the value of groundwater. There is no explicit marker for groundwater, but the value of land is a function of many other things, and one is a function of many things, and one of these things is accessibility to good quality groundwater. So you can retrieve information using this technique. Then the travel cost technique is mostly for using expenses to travel to a particular water resource, say something that has to do with recreation, a lake and so on, in order to retrieve the value of this particular water body. And there are many other techniques that allow you to combine market information in order to retrieve the value of not explicitly marketed water goods. If you have no market relevant, no market working close to your resource, then you need to use stated preference approaches, which are basically approaches that uses questionnaires to retrieve the data that you're gonna then use in econometric analysis in order to estimate the demand curve. And these are contingent valuation methodology, choice experiments, lab experiments, and so on. So at the end of the day, you have a list of different methods that will allow you to retrieve the value of water in different situations. And we've developed of this method, and we've been refining them for decades because there are no markets for water resources, and because there are no explicit markets, we have no explicit prices. So we don't have the value of the resource being a publicly available information. And without this value, we cannot complete the first step of our methodology of sustainable management of water resources, because this value is the basis of water demand. Water demand reflects the value people are willing to pay in order to use the resource in different productive or consumptive activities. Here I give you an example of the total economic value for marine water resources, and you can see that you have the use value, the direct use value, which is directly related to market outputs. And the example of market outputs is fisheries and tourists, and you can use market prices to retrieve this value. But there are also unpriced benefits like recreation and local culture, and in order to retrieve this value, you need to use total travel cost methodology and the hedonic pricing methodology. There you have indirect use value and price benefits, again, like CO2 sequestration, watershed protection, and so on. And in order to retrieve this, there are other production factor, function, and averting behavior techniques. Then you have the COSI and the option value, and the COSI option value, which is basically the willingness to pay a premium to preserve the ability of having this resource in the future in case you need it. And there are again examples of potential unknown biodiversity that can be used by future generations, and you can retrieve this value with contingent valuation and choice experiment methodology, and so on. Non-use values are there. They are very important. Usually, scientific evidence says that usually they are more important than the use values. So we cannot allow to leave them outside the water management framework. Because I don't have time, I won't go into detail to the rest of these values. And let me just say a few things on the Millennium Ecosystem Approach. I think the next presentation is also on this. Nowadays, we want to identify value through ecosystem services. So we divided ecosystem services in provisioning, regulating, cultural, and supporting services, and we identify for each sector of the economy which services it uses, and then we value these services. So this is how detailed economic analysis have managed to be with significant results on the management of resources. And once we have the first step completed, we have the characterization completed, then we construct the baseline scenario. Yellow line, baseline scenario, where we will be by a set date. The horizontal line gives you the time aspect without changing our ways, without any further intervention. And if we all agree that we want to become sustainable, environmentally, ecologically, economically, socially sustainable by this particular point here on the horizontal line, the date at which sustainability should be achieved, then the red arrow identifies the gap between where we will be without further measures and where we want to be. The second step of our manual, of our methodology, assesses the cost recovery of water services. That is, we need to know how we will close this gap between where we will be without further intervention and where we want to be. In order to identify this, we need the supply side of the story. So at the first step, we managed to identify the demand curve of water resources, and we managed to characterize the availability of water resources. In the second step, we need to identify how much these water resources really cost, who pays this cost, what is the current level of cost recovery, and also propose cost recovery mechanisms. And the total economic value of, let's focus on an example of groundwater, water abstraction. Total economic value will be the financial cost, capital cost, operation and management, administration cost, but also resource cost, foregone value of alternative uses, and also environmental cost, the quality reduction cost. So, as I indicate in this slide, you need to make sure that the total economic value, financial plus resource cost plus environmental cost, is paid by each user. So first, you need to calculate the full cost, and then you need to identify who pays and how much of this cost per economic sector. There's going to be a difference between the full cost and the cost that is currently paid. And each sector will have a different level of cost recovery. In order to close the gap between full cost and current cost recovery, you need to identify potential cost recovery mechanisms or investments that will allow you to close this gap. Once you close this gap, once you make the marginal user pay the marginal cost of its use, then you have an efficient allocation of water resources between users. And this efficient allocation should be identified on a particular, should be consistent with the physical scientist identification of what is perceived as sustainable water status. And once you achieve marginal cost equals marginal benefit, then you need to make sure that the people who will lose from this reallocation will be those who can afford to lose or will be compensated if they are in weak groups of your society. Which are the measures that you can use? Pricing, tradable permits, taxes, subsidies, standards, direct controls, educational and awareness campaigns, voluntary agreements, legal instruments. You can think about investments in pollution control and remediation, resource conservation and management, planning, land use, infrastructure, renewable energy sources. And each of these economic instruments has pros and cons. Standards and codes are not economically efficient. Water abstraction charges allow adjustment of price signals to reflect actual resource costs, encourage new technologies, are flexible, generate revenues, but low charges will have minimal impact on user behavior and will continue in resource overutilization. Each instrument has advantages and disadvantages, and based on your case study, you need to identify which is the most efficient, which will be the one that will support the sustainable allocation that is consistent with environmental sustainability, economic sustainability, and will then allow some allocation, equitable allocation of your resources that will be acceptable by your society. And financial institutions can also help in this sustainable water management development. And there are retail finance, corporate finance, asset management, and insurance are another set of instruments that are also very important in supporting the sustainable management of water resources. And of course, when you are identifying the triple, the sustainable management that adheres to environmental sustainability, economic sustainability, and equity, you need to do that within the institutional framework of your society. You have to take institutional characteristics and performance into account. Otherwise, nothing will work. What works in one country with a set of institutions does not work with another country. And our methodology introduces the way that you can take institutions into account. The third step, after you've identified the most efficient set of measures and investments, you have to assess this, the cost of your measures. You have to assess the impact of your measures, and at the final stage, you need to make a cost-benefit analysis. A cost-benefit analysis to identify whether you have disproportionality, which does not mean that cost exceeds quantified benefits, but disproportionality means that some weak parts of your population are severely affected, and you have to think about measures that will help you to redistribute the burden of an efficient allocation of water. In closing this presentation, I just want to bring to your attention the big issue of long-run discounting. Discounting is not so straightforward, and when you are trying to implement sustainable water management and you are trying to support sustainable development, then you are faced with the problem of doing a cost benefit analysis with constant discount rate. If you do a cost benefit analysis with a constant discount rate, then you even for a very low discount rate, any benefits that come after 50 years will just become equal to zero. In order to do cost benefit analysis on a project that aims to support sustainable development into the very long run future, then you need to rethink the discount rate. And my team has done a lot of work, and many other scientists the last 15 years, on what is the appropriate way to discount long-run projects. And it seems that the discount rate that one needs to use is a declining function of time, and this is not something that we propose a priori. It's something that derives from economic theory if you introduce uncertainty of economic growth into your theoretical economic model. So a time declining discount rate, the first 30 years 3.5, from year 31, if you look at the slide, to year 75, 3%, 76 year to 125 a year, 2.5, and then it reduces to 2%, 1.5%, 1%. So if you are looking at any project with long-run benefits, then your discount rate should be declining, and the difference between applying cost-benefit analysis with a constant discount rate and a declining discount rate is huge. For the first 30 years is insignificant, but if the benefits of your projects are gonna continue to come after year 30, after the 30th year from the start of the project, which is by definition what is going to happen if you are introducing sustainable management, because sustainable management by definition means long run, caring about the long run, then the difference between doing cost-benefit analysis with a constant 3.5% discount rate as compared to a declining discount rate could be 50%, 100%, 150%. This means that the benefits of your project could double if you are using the socially efficient and economically efficient discount rate. So water management with a 3-step methodology, and at the end of the day, when you're doing cost-benefit analysis of the interventions your methodology suggests, use a declining discount rate. In this way, you can really support projects that are going to change the world. They're going to change the way we use our resources. Thank you very much. Thank you for inviting me to give this presentation. And I really do hope that we're going to have an interesting session with questions and answers. Thank you.